power to power rule? Power to power rule states that when you take a power and raise it to another power, you simply multiply your exponents. So if you look at one of the examples given down below, kind of below the definition here, you're given 5 to the second power. You're raising it to the third power. So this is your power to power. When you have a power to power, we'll set it up like this, 5, and we'll have 2 times 3 giving us 5 to the 6th power. So down below it says, again, simplify using only positive exponents. We have 2 to the second power raised to the power of 4. Now, there's a couple ways you can really figure this out. One way is telling you, hey, you can write 2 to the second power out 4 times, and that's multiplying. So 2 to the second times 2 to the second times 2 to the second times 2 to the second. Same base. When you have the same base, you add all the exponents. So we have 2, 4, 6, 8. And we'd add them all together. This would be one way. The long way to solve, which I would recommend not using. Since you know the power to power rule, it would be much more efficient knowing that power to power you simply multiply. So you have 2 to the second power. It's raised to the 4th power, so we'll multiply by 4, giving us 2 to the 8th power. Much more efficient than the previous way. And then we could go ahead and compute 2 to the 8th power, giving us 256. Example 2, you have 3x to the 3rd, and that is raised to the 4th power. Now again, you can write out 3x to the 3rd 4 times the long way. Otherwise, go ahead and raise power to power. You need to be careful. There is one mistake that a lot of people will have. Everything is raised to the 4th power, meaning the 3 is raised to the 4th power. This really has an exponent of 1, and x has an exponent of 3. So what I like to do is take everything out of inside your parentheses and raise it to the power of 4. So here's 3. This did have a power of 1. We're going to raise it to the 4th power, so we'll multiply by 4. And then we'll deal with the x. We have x to the 3rd power, raising it to the 4th power, multiply. We have 3 to the 4th and x to the 12th. We can simplify further, figuring out what is 3 to the 4th power, giving us 81 x to the 12th. Power to power, multiply. Example 3, pull everything out again. So again, 4 has that exponent of 1. I'm going to take care of the 4 first. We have 4 to the 1st. We're raising it to the negative second, so times negative 2. We have x to the negative second power, and we're raising it to the negative second power, so multiply by negative 2. And we have y to the 3rd, and we're raising it to the negative second power. Work down our paper. We have 4 to the negative second. We have x. Negative 2 times negative 2 is a positive 4. And y to the negative 6th. Reminder, we don't like dealing with our negative exponents here, so we need to get rid of that negative exponent. In order to get rid of the negative exponent, if it's not a fraction, we'll make it a fraction. So we'll make it a fraction, and we'll move everything that has a negative exponent. So the negative exponents here, we'd have y to the negative 6. Circle it. We know that it'll move to the bottom. When you move it, it gets rid of the negative exponent. 4 to the second power, negative exponent. We'll move it to the bottom. So left on top, we have x to the 4th. On the bottom, we now have 4 to the second, y to the 6th. Now we can simplify it even further. We can figure out 4 to the second power. So we would wind up with an answer as x to the 4th all over. 4 to the second is 16 y to the 6th. Example 4, you have a fraction here. The fraction is raised to the 4th power. So basically deal with your numerator and your denominator. I'll go ahead. Here's my numerator. We have a to the negative second. Here's that power to power. So we're going to raise it to the 4th power. And on the bottom we have b to the 3rd. And that is being raised to the 4th power. Go ahead, do your computation here. We'll have a to the negative 8th over b to the 12th. We would not be finished here because we still have a negative exponent. So we'll move the negative exponent, that is a to the negative eighth. You move it to the bottom. When you move it to the bottom, you now have a to the eighth on the bottom over b to the 12th, and if there's nothing on top, we'll simply throw the 1 up there, and we have 1 over a to the 8th, b to the 12th. Example 5, tying a couple lessons here together. We need to take care of order of operations, so take care of our exponents. Exponents meaning we would be taking care of that power to power. Power to power, we multiply. So we have 2 to the 4th. That is raised to the 4th power, so we're going to multiply it by 4. And then we are dividing by 2 to the 16th. So do all your computation. We would get 2 to the 16th here when we take a power to a power, and we are dividing it by 2 to the 16th. Now if we look here, we have the prior lesson quotient of powers rule. We have the same base. We are dividing. When you have the same base, you keep the same base number, and when you divide and you have the same base, you subtract exponents. So we have 16, take away 16. We get 2 to the power of 0. Anything to the power of 0 gives us 1. Last one here, again, a fraction, and we're raising it to the 4th power. So we need to take everything to the 4th power here. So first things first, we will take the 2 here. We have 2 to the 2nd power. That is being raised to the 4th power. So multiply by 4, taking care of the 2 on top. Also on top we have 5 to the 3rd power. That is being raised to the 4th power. Now this would all be over 15 to the 3rd power, which is being raised to the 4th power. Now do all of your computation. When you do your computation here, we would get 2 to the 8th power, 5 to the 12th power, all over 15 to the 12th power. Now everything looks like it should be able to be completed and done here. It's not. What you need to do is almost prime factorize the bottom, because we can reduce this even further. 15 is made up of 3 and 5. So basically what that is telling you is you have 12 3s and 12 5s. So another way to write this problem is you're still going to keep 2 to the 8th and 5 to the 12th on top. And all I did is prime factorize this 15 to the 12th power. I put it into 3 and 5. 3 and 5 giving us the 15. And they're both raised to the power of 12. So when I put this down below, 3 to the 12th and 5 to the 12th, looking at this problem, you can reduce this even further. On top, you have 5 12s. Cross that out. On the bottom, we also have 5 12s. We can cross that out. So basically, what we would wind up with is 2 to the 8th power over 3 to the 12th power. So prime factorize where you can to help simplify. This will conclude power to power rule.